Let's understand what is decision tree in this video. Decision tree is basically a type of model suitable for classification task. And there is a variation to this model called regression tree, and we can use that for regression tasks as well. It is basically a tree structure to represent possible paths and outcome for each path, so we can predict the label that we want to predict. I know this is a little bit abstract. Let's look at an example now. Imagine that we are back in the COVID pandemic time and we have a bunch of patient data, and using the data we want to identify who should be isolating and who don't have to isolate. And the data we have two different features. The first one is symptoms and the second one indicates whether the patient have had any contact with someone who is tested positive for COVID. With these two features, we'll be working out whether that particular patient should isolate or not. So, if you look at here, this is actually very simple process. We first check whether that particular patient has symptoms, and if the patient has symptoms, then we ask them to isolate. If the patient doesn't have symptom, then we check whether they have had any contact with someone who is tested positive for COVID. If they do, then we will ask them to isolate. Otherwise, we don't ask them to isolate. So this is pretty simple. And this is an example for valid decision tree. And one thing that we need to keep in mind here is that it doesn't have to be binary branches like this all the time. The branches has to be decisive, but they don't have to be binary like this. So we could have multiple branches. As long as each of those branches are decisive, then that is fine. So for example, we may have age as one of the feature here, and if we have age as one of the feature, then if we assume that the patient age is between 1 and 100, then we could technically have 100 different decisive branches coming below the age decision box. Okay. Now let's look at an example which is not a valid decision tree. So if you take this example, this is very similar to the one that we have on the left here, but the difference is if the patient is having symptoms, then we have two paths here. So these two are valid paths if the patient has symptoms. But if you look at here, this is not decisive. If the patient doesn't have symptom, then we have just one path to follow. But if the patient does have symptom, then at the same level, we have two options, which means this is not decisive. We can't choose one over the other because both of them are applicable if the patient has symptom. So this type of tree is not a valid tree because they don't have decisive paths. Okay, so because of this is not a valid decision tree. Now, you might wonder, the decision tree that we have seen here is pretty much how one would develop a system using traditional program to work out whether the patient should be isolated or not, right? Because using traditional program, we will create branches and loops which will represent this type of tree, and that will tell us whether the patient should isolate or not, right? Then why are we calling this as AI model? So decision tree is one of the AI model. Why are we calling this as AI model? This is because we don't develop this decision tree using traditional programming process. Instead, we will develop this decision tree using the AI model training process using the data. So we will use the data, and with that data, we'll come up with this decision tree through the training process, just like how we will develop any AI model. So there are different algorithms to do that. Here are a couple of examples, ID3 and CART. There are other algorithms as well. So using these algorithms and the data that we have, we will come up with this tree during the training process. So this is why decision tree is also one of the AI models. So the branches and leaf nodes that we will have will depend on what type of data we have during the training. Okay. So once the model is developed, we can use it on unseen data to predict the outcome. So like I said previously, the labels doesn't have to be binary. In the previous example, we have only seen two options, which is isolate and don't isolate, but it doesn't have to be that. We can have any number of labels and the decision tree will work perfectly fine with any number of labels. And also the paths that we have below each of the node doesn't have to be two. There can be any number of paths It's just that they all have to be decisive without any ambiguity. That is the only requirement. Okay. That is all I wanted to cover in this video. I hope this is useful. Thank you.